to do Advent Code 2019 Day 3 using Go. And I don't have my usual partner here, so I'm going to be talking to this guy, explaining to him what's going on. He can be helpful at times. Alright, so let's start with a question. Alright, you can go read this if you want to, but pretty much what they are telling us is that we have two wires that start at some origin. They don't really tell us that it's 0, 0, but it doesn't really matter. And they give us instructions like this wire goes right 8, and then up 5, and then left 5, and then down 3. Hey Ray, welcome. So we're just getting started here and just describing the problem that we're working on here. So this wire is defined by how it moves from the origin. And then they have a second wire, which has its own definition of how it moves. So it goes up 7, right 6, down 4, left 4. All right. And what they want us to figure out is where these two wires cross, and where they cross closest to the starting point. So you can see that they cross here and they cross here, but we want to return this one here, because this one will be closest to the origin. And then also for measuring the distance, we're using something called the Manhattan distance, which is really just the length and then the height added together. So you don't have to figure out square both of these, then take the square root to find the actual distance. It's just length and height. Makes it a little bit easier for us. All right, so they give us a couple of examples and what that distance would be. And then let's not forget the easier example that they gave us up there. And then the question is, what is the Manhattan distance from the central port to the closest intersection? Okay, so I like to start off by writing a couple of tests, so that as we code, we can see that it's working as expected. All right, so we got a hey Bloodluster, welcome. We'll start off with the main test.go, and we'll test our result function, which we haven't written yet, but we'll put the data in there. All right, so let's see. We're gonna have some cases, and they're gonna have, say, a wire 1, a wire 2, and then an expected distance, which is going to be an integer. And let's see, so let's set up. We're going to have 3 of these at least that I can see from the text. So let's go grab those. All right, so here's the first wire's path. And put that there. And then let's see, here's the second wire. And let's see, they give us the distance here. All right, it's one test case. And then this one, we'll add this as well. Also, if you guys have any questions, just you can see that the chat is right there in my face, so please feel free to ask away. That's what I like about live coding. All right, and I'm just gonna format this to look a little bit nicer. I don't like it to go past where I can see on the screen. Yeah, let's use the mouse. All right. So there are our test cases. And then we'll just range over these and we'll make a sub-test case. We'll just name it the the number that is its index in the case. And then we make a new testing function. And then here we'll say, all right, so our actual will be result of, let's see, c.wire1, c.wire2. And then we'll say if our expected does not equal our actual, then we'll t.arf want this, got this. So we wanted this, and this is what we actually got. So now we just need to go make the result function, which does all the work. All right, so create a new main.go. We'll have a func main, we'll do that later, but we're more interested in this result function. So let's just call these wire1, wire2 string, and they return an integer. And for now, we can just return 0, make sure our tests at least run, they should all fail. Okay. And now we have to go figure out what to do. All right, so how's everything given to us? All right, so we have directions. It always starts with the up, down, left, right to indicate the direction, and then it's going to give us a number. It might be tempting to want to create some gigantic two-dimensional array to kind of store all the points that we visited with this wire, kind of similar to visually what we see here. It could work for some rather large inputs. As you can see, even the test data is starting to approach rather large inputs. One, wouldn't be efficient, and two, I think there's just really a better way. Hey, Equal Emperor, thank you for joining. So really what I want to do is I want to think about each path as segments. So I'm going to create a struct for this, and each segment is going to start at some x and y position, and it's going to end at some x and y position. I'm going to pull these segments out of the input, and the combination of these segments will be our line. So we're also going to have a type. Give me a second to come up with a name for that. And essentially it's going to have a list of segments inside of it. So we might call this, I don't know, let's call it line. Okay. So let's say that let's create, let's see. So we need to parse wire 1 and wire 2. So we'll say parse input wire 1, and then parse input wire 2. All right, and what do we want to do with that? So let's make wire 1 line, and then we'll say that segments are equal to the result of parsing that input. And we'll assume for now that we're not going to have errors in parsing. So, all right, so we have 2 wires, and then we'll need to know where they intersect and at which intersection is closest to 0, 0. We'll call that our origin. So parse input, we take some kind of string, and we're going to return a slice of segment. All right, so our input is comma separated, so we'll split by that. And hey, Commander Root, and we're gonna go over that, go over the list of up, down, left, right. So we have, and then create our individual segments and append them to a list that we have. So we'll say segment, and then let's see. Let's say handle up, down, left, and right. And then the rest of our input is going to be the length. So the length is going to be, we'll have an error returned here. So we'll do ASCII integer, and then we'll do our input, everything past where we say, up, down, left, right. We'll do some print lines to kind of see that this is working. All right, so let's see. So why do we care if it's up, down, left, right? We'll figure that out in just a second. So let's say, let's make a previous one, because in order to know where any of the later segments start, we'll have to know where the previous one ended. There's a couple ways we can do that. Let's start now by just having kind of a dummy variable for previous, and then we'll work from there. Maybe there's a better way. All right, so we can say that our start x and our start y equal the previous end x and the previous end y. Hey, Mikhail, welcome. Okay. So then we'll have, so we can go right ahead and, and make our segment here. And instead of putting these in the local variables, we'll just start building our segment. And that'll be start y. Yep, we'll get to that. All right. So, all right, if we go up, then what can we say about our index and our ny? Well, our index will just equal the same place that we started, because we're going up, so there's no change in x. And then we'll say that our end y equals our start y plus our length. Could be minus our length, as long as we're consistent. It's really not going to make a big difference to finding the actual answer. So, whether you use plus or minus here is really just about the orientation of your coordinate system. So same thing with down, and we'll just have to make sure that this sign is reversed. All right, and then if we go left, things will be a little bit different. So our end y will now equal our start y, right? And then it'll be our our index that'll change. So if we go left, let's say this is minus length, and then going right will be plus length. And then since this is not returning an error yet, I might change it. Let's just handle the case of not having any type of direction that we could actually parse. So unknown direction %C. And we'll just pass in what input 0 was. Okay. And then we'll want to add this to our segments. And then we'll want to set our previous to seg. A couple different ways we could do this, like up here, where we're saying, again, I'm not returning an error from this function, so not usually ideal to panic from here, but for our purposes of trying to solve a problem, it should be okay. All right, so I was saying about previous, like we could go back and check if there even is a previous. It might be a little bit cleaner. I think we're okay doing it this way. And then what was our goal? So our goal was to return a slice of segments, which we have. So what I'm going to do for debugging purposes is I'm going to add a string function to segment, and I'll make this like a, so you can see now in the IDE we have this green interface implementation, or in Go they call it a satisfying interface. So now they're saying that the type segment satisfies the stringer interface. If you click on that, you can see stringer. And I just want to use this for debugging. Now, one thing I'm not storing is I'm not storing, which way it went. Maybe for debug purposes we could. So we could say direction, we'll call it rune, or it's called byte, because that's technically what we're doing. So we'll say that the direction is input 0. All right. And we could put in a length there too. Why not? So our length is length. All right. So let's try to output some useful information here. So we'll return this, and let's start with just kind of returning the way that it was originally given to us, which is the direction and then the length, and then we'll say start at here and then end at here. Yeah, sound good? Then we'll do start direction, or segment direction, the length, start X, the start Y, the end X, and the end Y. All right. And let's go fix some errors so we can compile. All right. So we'll fix that later. So right now I just want to see that, hey, if I parse this input, am I getting back what I expect? So let's create just a kind of, sure, that's a good name. So we'll say path is equal to this, and then I want to parse my input, which is like this path, and I get back from it a list of, a slice of segments. Just range over that, and then we'll print out S, and then, or seg rather. So that's our individual segments. And then for good measure, we'll print out the initial input in case we want to test this with more stuff. We'll end up deleting this function, but no big deal. All right, so I just want to test this one function. So let's flip back over here, do go test -v, run that. All right. So right 8, rather, up 5, left 5, D3. So we end at All right, so possibly I messed something up already. Oh, no, no. Right, it's X and then Y. So we go right 8, okay? So, okay, yep, we can see this went right 8. And then our next segment starts where the other one ended. It's kind of like a tip to tail. And then we go up 5, okay? So we add 5, and then we go left 5. So we would subtract 5 from 8. So then we have 3, 5. Then we go down 3, so we would subtract 3 from 5, and we end up with 3, 2. So it looks like we have a good slice of segments. We don't really need this function anymore. And then now we need to know where these intersect. And maybe I want to get all the intersection points. I'm not quite sure. So let's say intersections equals, I guess, make our function call it intersections. So intersections of wire 1 and wire 2. We don't need that anymore. So let's go make that function. Call these W1, W2, and these are now wires. Sorry, they're lines. And then we're going to return back. Let's call this point, just make a new struct called, or a new type called point, and then we'll just return back a list of intersection points. So how do we find out if anything in wire 1 and wire 2 intersect? Well, first we need to figure out if 2 segments intersect. So let's go range over all the segments that are in wire 1, and then all the segments that are in wire 2. Right? And then we want to know, does intersect. I will definitely come up with a better name for that one. Then we want to test these 2 segments here. Call this yes, intersects, and we'll make it a bool. So if they do, then we'll add the point. Okay, so we'll have this actually return the intersection. No. Wait. Yeah, so we'll have it return, a point and then an okay. Okay will indicate that yes, it did intersect. Point, if it didn't intersect, we'll just return the 0 value, which would be like an empty point. And then we'll say, okay, as long as these intersected, then go ahead and append this point to our intersections. So, hey, Community Showcase, welcome. All right, and then here we'll just return the intersections that we have. All right, so we need a new function, and this function will tell us if 2 segments intersect. So we'll have S1, S2, segment, and then here we'll return the point at which they do intersect, if they do, and then a bool, which says that either they do or do not intersect. Okay, so let's remind ourselves that a segment has start X, start Y, and has end X and end Y. And we want to find out, given 2 sets of these, whether or not they intersect. So pretty much what that means is that let's make an assumption that these segments are perpendicular. So one's horizontal and then one's vertical. We'll verify that that's actually the case between the 2 segments that we're looking at. But let's go ahead and start with that assumption. Now, what could we say is true about these 2 segments? Okay, so for our vertical line, it's going to have a constant x. And then for our horizontal line, it'll have a constant y. Now, what we want is that for the horizontal line, its start x and end x must be within the, like, okay, so the x point of the vertical line will have to be within those bounds, right? Hopefully that makes sense. And then vice versa. The other line will have to be within the bounds. So let me just kind of draw like a little. So let's pretend that these are some lines that do intersect, right? So this x is constant, and then this x contains the other one, and then likewise, a horizontal line, the y is constant, and its y value is contained within between start x and start y of the other line as well. Now, an example of some things that like would not work, these lines would not intersect, is, let's say that we had these lines or these segments, right? So these would not intersect. We can see that visually, but we could say that, hey, this one is within the y bounds of the other one, but this is not within the x bounds of here. Right? Hopefully that makes sense. And let's go ahead and get on with doing that kind of math. All right. So since we're passing these as copies and not by reference, I'm going to be okay with modifying what's actually in these segments, because I want to get them into a form that's more suitable for comparing, without it's kind of just to reduce the number of if statements that we have. So what I want to do is I want to make sure that the start x is always less than the end x, right? And then I want to make sure that the start y is always less than the end y. It'll make it easier to compare it's between. Otherwise, you'd have to go, well, if I started here and ended here, it would get messy. So I'm gonna do that first. Actually, the first thing I'm gonna do is verify lines are perpendicular. All right. So how can we do that? So if s1 start x equals s1 dot end x, okay, so our s1 is the horizontal line. So we're gonna have a little bit of an iterative approach on this one, because it's not, unless you do this kind of geometry, it's not immediately obvious exactly how you would approach it. All right, so here we would say that S1 is the horizontal line. Okay, and that's good. Now I might say if S2 dot start x equals S2 dot end x, S2 also horizontal, and then just leave. So we might write like kind of a naive implementation at first, and then we'll kind of make it more concise later on, once we're kind of sure that we're doing the right thing. All right, so this is just going to take care of. So actually, I apologize. I have this wrong. So if the x's are the same, then it's a vertical line. All right. So here we just need to change this to start y, end y, and then start y, end y there. So if they're both vertical, then get rid of it. Okay. So it might also help to say, hey, I want either S1 to always be the horizontal line, or I always want it to be the vertical line. Again, for just kind of making things simpler as we move down this function. So here I might say if s1.startx equals s1.endx, right, which would be horizontal, which would be vertical, then I actually want to, if s1 is vertical, swap s1 and s2. Make s1 always horizontal. And this will help our comparison later on. So here I'll say s1, s2 equals s2, s1. And that's just a nice way of swapping these two values. All right. So they are, so now at this point, things that we know. All right, so we know one, let's see, S1 is horizontal. We know that S2 is vertical. Okay, so so this means that the S2 start x is just going to be its x, and then S1 start y is just going to be its y, and then we can use that to compare it to see if it's in between the other one, start x and start y. So let's start writing that, and then we'll see if there's a challenge that comes up, and then we can make an adjustment. So all right, so I know S1 is horizontal, so let me start by saying S1y is going to be S1.startY, because we know it's start y and end y are the same for S1. It's a horizontal line. And here we'll say S2x is S2 start x. So this way it doesn't get confusing to us. It's like, well, why are we looking at the start x of this one? Because they're always the same. It'd be helpful to have this into like a variable that kind of says that, hey, S2 only has one x and S1 only has one y. All right, so I want to say if S1, now what changes about S1? So it's a horizontal line, so its x changes. If S1 start x, and we're gonna run into a problem here, but we'll fix it in a second. Okay, so if it's, all right, if it's less than or equal to S2x, or let's make this a negative case. All right, so if S1 start x is greater than S2x, or S1.endx is less than the S2x. Right, I know there's a problem here if you guys already see it. I'm going to take care of it. So what are we saying here? All right, if my start x, so let's say I start over here, but if that's greater than my S2x, right, which would be like over here in that case, then we're already out of bounds and there's no sense in continuing, right? Now, additionally, I have an index, and if my index is less than my S2x, then, you know, the S2 is no longer intersects. The challenge that we have here is that we don't always go left to right, we could go right to left. So we might want to normalize and say, let's always make the start x the lower of the two. So because we don't really care if it's traveling left or right, so we can just we can flip them if we're going into, say, like the left direction, right? So make sure start x is less than S1.endx. Uses comparison. make sure S1 start X. Alright, so if start X is greater, then we just want to flip them. And do S1 and X, S1 start X. And we're probably going to want to make sure that the same thing about the Y's for S2. So if those Y's are traveling in a direction that's not mathematically convenient, then we'll just change it. And we'll just update our comment. Make sure S2 start Y is less than the S2 and Y. Alright, cool. So, alright. Now, alright, so this will say make sure S2 is within the X range of S1. Right, and here we'll make sure that S1 is within the Y range of S2. Alright, so we'll change these around. So I was saying about having just one variable for S1Y and S2X helps us out. S2 and Y. Alright. Okay, so now they're all, it's perpendicular, and we've decided, we basically determined that they do intersect. So at this point we can return a point. And kind of the cool thing is that where they intersect is, exactly at the, let's call this, at the X and Y values that we pulled out earlier. Right, and then here we get to say true. Alright. Bit of a longer function, but pretty much the kind of the one that involves like the most, I would say, I don't know, attention to detail. Alright, so we have a number of intersections and we just want to know which one is closest to 0, 0. Hey, enter GoProf, enter in Woozy, welcome. Alright, so we have our intersections, and now we just want to find which one's closest. Alright, so let's start with min equals, let's do max in 64, right? So we want to go through our intersections and find out which one is closest. We'll be doing a comparison with what we have, and then we want, at some point we want to say less than min, so if we start off with max in 64, I'm pretty certain that those will be, alright. So now we need to get the distance between 2 points. So specifically for this one, we just need to know the distance between 0, 0, so we'll just make a function called dist. We'll put in a point and we'll return an integer. And this is going to be our point x, but not just that. It's going to be the absolute value, and then plus our point y, right? And then we create a little apps function. Let's say if a is less than 0, return negative a, otherwise just return a. Right. And then let's not forget to do this. Absolute value p dot x and p dot y. Alright, so we'll say d is our distance from the intersection. Now we can say d is less than min, right? So in our first iteration, hopefully it's less than max in 64. And we'll just say min equals d. Alright, and now actually what we can do is return min. I'm not sure that there's anything else to do. I don't really have anything in my main function. I guess that would be for saving loading up the actual data that we're gonna get. So alright, let's see if we did it right. No, we got a bunch of zeros. Why did we get 0? Let's see. Go into our intersection instance. So return false, return false, return false, return true. Okay. Some reason we're getting. All right, so let's print out what we're getting to. See what's going on. All right, so we got an intersection X, intersection Y, and then let's throw in our distance in there too. Why not? So dist to 175. If d is less than min, then min equals d. Return min. Probably has something stupid going on. Oh, so we're getting an intersection at 0, 0, which is comforting. What's not comforting is it looks like we're already not getting the right values, but that's okay. We'll deal with that. So why are we getting an intersection at 0, 0? It did explicitly tell us that those intersections were not valid. Let's see. So let's say if s1x equals 0, sorry, s1y, and s2x equals 0, we're not gonna count intersections at the origin. So we'll return an empty point and false. And let's check quickly that we don't have anything just kind of like flopped around. So S1, let's start up here. So we make sure that they're perpendicular. Start X. All right, so these are both vertical. Don't count it. Start Y and Y. S1 start X equals S1 end X. Then make sure that S1 is always the horizontal. Okay. So we're interested in our horizontals Y and our vertical ones X. If where they would intersect is at 0, 0, then discard that. All right, and then if S1, oh, here we go, already. So that's what we missed. All right, so we accounted for the 0, 0 problem, and then we fixed at least one kind of copy paste error. So let's see what we got. All right, so our test passed, and then we can actually see all the different distances where they intersected, which is kind of cool because they didn't really ask for that, but it's nice to see that there are more than one intersection. All right, so we don't need to see that. Comment that out for now. And go test. Okay. Now I need to go grab our actual input. So let's save this link. Give me a second here. So I'm gonna save this as, let's call it input txt. All right, and let's go to, why am I confused? I don't know why that was there. Okay. All right. So if we look in here, we have our input txt. So this is our input here. So 2 lines, some gnarly looking input. And then we'll leave that there just in case we need it. So let's read this file. Input.txt. Read it as a byte slice. Error is not equal nil, then we'll just flag fatal. And then we'll do a bytes dot. And let's convert this to a string. Alright. I get to ban my first person. Not sure how to do this. Phoenix 87. Okay. Thanks for stopping by. Alright, so we'll say our input, just convert that byte slice to a string. Alright, and we want to do a string split. And we want to split by the new line separator so we can get our different parts. And we will live like there's no tomorrow and assume that our input is good. And we'll say, hey, our answer is this, and we'll just say answer %d. All right. So let's go run dot 209. Let's see if that's right. Cool. We got the first part. I'm gonna do part 2, and then I gotta get ready to go somewhere for the weekend. But all right, let's move on with part 2.